It's 1:30, so I'm going to go ahead and get started because there's quite a bit of content that I tried to pack into today's talk. Hopefully you're here for effectively managing multi-cloud environments. I'm really thrilled to be here sharing with you some of my experiences and ideas about how to reduce our headaches when it comes to managing our cloud environments, and really thankful for this virtual opportunity from VMware. First and foremost, hello to everyone. My name is Bree. I'm a master software engineer at Capital One. I consider myself mostly a backend and infrastructure site reliability engineer. Lots of experience building applications in the cloud environments, whether they be cloud native, legacy to cloud, unregulated to regulated cloud environments, just lots of different opportunities building and deploying applications in the cloud. I'm also one of the 2020 Women Who Code Leadership Fellows, and I co-lead our cloud and Python tracks there. But enough about me. Let's get into why you're all here today. Let's level set some expectations of hopefully what you will be able to walk away from today. First, I always think it is important to ground our conversation and why you attending this talk, spending 30 minutes with me, is important. So we'll talk a little bit about our why and some use cases. Then I'm going to share some general broad tips to put in your back pocket when thinking about managing multi-cloud environments. Then I'll dive into my 3 favorite cloud provisioning tools and what I'm calling the triple threat of automation, and some of the tips and tricks and anecdotes around using those tools to effectively manage our cloud environments. And hopefully we'll have time at the end for questions. So first and foremost, why might you be here caring about this talk? In order for us, there are 3 reasons. In order for us to really leverage the power of just the cloud in general, and having the flexibility and the power behind multiple cloud environments or different cloud providers, we really have to embrace some of these ideas that we're going to be talking about later today. And you might be, coming to the idea of multi-cloud for a variety of reasons, right? Maybe it's because disaster recovery is of utmost importance in your organization, and it is imperative that you're running in 2 cloud regions because you just never know what's going to happen at the end of the day. Or maybe having the flexibility to move because a new partnership opened up with GCP or Azure, or the cost has greatly been reduced by moving to AWS, and being able to harness and leverage that power and that flexibility is really important in order to build effective and reliable and cost-worthy solutions. Second reason why you might be here is you're concerned with your testing reliability and you're increasing the quality of your application that you're delivering to your customers. In order to be able to really guarantee and ensure that our applications are tested, ready to go, ready to be shipped in front to our customers, I think it's really important that the testing that we do runs in an environment that either mirrors production very closely. Like if you're doing performance tests, that environment needs to be very one-to-one, spot on matching our production environment, so we really can understand the behavior that our application will exhibit under true customer load, right? Or if your application mimics production, so we're testing new features in our dev and our QA regions. And I feel like a lot of times our testing reliability decreases because we're afraid or we don't want to put up with the headache of being able to manage and provision multiple environments, especially multiple environments spread out across different cloud providers. So if you want to increase that testing reliability, the quality of the solutions that you're delivering, you're in the right spot. And most importantly, what I think we're all aiming to achieve is some headache management, whether you're an engineer deploying your own applications, a sysadmin managing a large cloud infrastructure for a variety of different teams. Headache management 101 is our game. And having being able to take in some of these principles and ideas and having a true understanding of what exactly is running and how it is running keeps our infrastructure manageable and headache-free for absolutely everyone involved. So if you fall into one of those categories, hopefully you're in the right spot. So as I mentioned, I'm going to start with some general ideas. I love this quote from Albert Einstein. Most of the fundamental ideas of science or computer science are essentially simple and may, as a rule, be expressed in a language comprehensible to everyone. I think it's really important to take away, all of the complexities of the different toolings that we could use to solve our problems and think about our solutions in really simple, fundamental ideas. And hopefully these three paradigms, these three thought patterns, three rules that I will express to you here, you'll be able to digest, comprehend, and apply whether or not you take away my tangible tooling and infrastructure tips later on in the talk. So first and foremost, the thing that we have to master, this is like absolutely primary key. I think I say this in every DevOps or infrastructure talk that I do. If we don't master this, all is lost. Infrastructure as code, point blank, period. We have to maintain the same practices and mindsets about our infrastructure code as we do with our application code. So making sure it's tracked, it's shared in a version control system, absolutely everything from files to configurations to services recreating, everything needs to be as code. And as you start to think about building simple, elegant, repeatable code, I think the headache of creating infrastructure as code, and when you pick the right tools, goes out the door, which is usually what stops a lot of folks. Everybody assumes that logging into a box is a lot simpler, but at the end of the day, trust me, it'll save you much more time once we get our infrastructure as code first. Second key principle to keep in mind in managing multi-cloud environments, and I think it's important to note that, if you're in the box of reducing headaches or even increasing testing reliability, it doesn't necessarily mean that you have to manage multiple cloud environments. You could just be in all AWS, you could just be in all Azure, right? But if you have a dev, a QA, a prod region, these things still hold true. So second tip idea, decouple your choices. And when I say choices, I'm talking about two parts of when we're provisioning our infrastructure that we get to choose. The first is what exactly infrastructure we are choosing. So I'm talking about if I have a queue. I need to build a queue for my application to be able to dump messages into. Here you have a choice of going into a completely managed service, a slightly managed service, or something that you manage yourself. And this is a really gray area that is going to take time with you and your team, deep diving and weighing out the pros and cons of, setup time, how quickly if you know for a fact that you're going to be in GCP and Azure, right? It probably doesn't make sense to box yourself into a managed service, but this is not as clear black and white of a line to draw here, but it's something that you have to keep in mind. Are you coupling yourself into a managed service for simplicity up front that's going to create a headache a month down the road when you no longer have that managed service in GCP and AWS because we've switched providers? Second choice you have to make is about the tools that we are using to provision this infrastructure. Similarly, when we're choosing infrastructure, we can box ourselves into a cloud provider. You can do the same thing when you're looking at what tools should I be using to create my load balancers, my compute nodes, right? And keeping that at the forefront is of utmost importance. And to me, this line is really black and white. Don't choose a tool that's going to couple you into your cloud provider because there are so many well thought out, well developed tools and capabilities that you can leverage in order for you to deploy your infrastructure. So that's kind of more black and white. And finally, really simple, keep it simple. You don't have to think about building a complex code solution when we're thinking about managing our infrastructure as code, like I mentioned before, there are lots of industry standard tooling that, you know, lady DevOps off the street can come into my organization and my application and know exactly how to use and be able to get up and running very quickly and seamlessly and effectively in provisioning and managing my cloud infrastructure. You really, if your mind immediately goes to like building this robust, complex solution, creating a custom wrapper around the AWS CLI and the GCP CLI, take a step back and you know, go and evaluate what tools already exist. It's just like our application code, where we don't reinvent the wheel for going through files. We import a library in order to help us with that. We want to do the exact same thing with that infrastructure code, keeping it really simple and keeping it industry standard. So we have those 3 ideas in mind. What do we actually need to do? Let's move a little bit more from theoretical into actually tackling tangible problems. And I think you have 2 options that are, or 2 things that you need as an infrastructure creator. I wouldn't say necessarily an infrastructure engineer. You could be a developer making your own infrastructure, right? But as an infrastructure creator, you're going to need to be able to create services and resources. So the things that are actually being provisioned and stood up that you're going to be utilizing. And then you need a way to configure those services and resources that have come up. Now, sometimes, especially when it comes to services, they're not as separate and decoupled. But if you think about, I'm provisioning a Linux box, right? I'm creating a resource and telling it what it should look like, its size, its CPU, its memory, and then I need to configure it by installing applications, installing agents in order for my application to be able to run on it. And in that comes my 3 absolute favorite tools. And I think I cannot, to this day, think of a use case in which I haven't been able to solve building and managing a cloud environment without these 3 tools. And they help us keep to the 3 ideas that I originally presented. So keeping our infrastructure as code, everything, it is code. It's kind of like your language, this is like your Node, your Python of sorts, right? It helps us decouple from our cloud providers. All 3 play very nicely into the major cloud providers. They also offer, like Terraform, for example, you can create your own configurations so that you can input with your on-premise data center. Maybe you're going hybrid or in your multi-cloud strategy, right? There's flexibility. There's a ton of industry standards built into these tools, lots of great documentation. I know Terraform for a fact has a certification, right? I can pick up engineers off the street, drop them in, they're ready to rock and roll and manage my cloud infrastructure. Also, I love built-in documentation as a service, is what I like to call it. When you use these tools to specify your infrastructure, inherently with the way that you have to configure and write out the files, you get built-in documentation. And, you know, people come up to me and are like, Bri, what's in your dev, QA, prod environment? Like, very important higher ups. And I can very confidently go and look at these code bases for the different parts of my infrastructure and be like, 50 Cassandra nodes in prod, 20 in QA, you know, and because that built-in documentation is there. I also say, and sometimes Python, because let's be real, there are some unique use cases in which I need to script a little bit more, but for the most part, these 3 solve all of my multi-cloud, multi-environment, multi-level issues when it comes to provisioning infrastructure. Now there's a caveat. No tooling is completely 100% cloud agnostic. Unfortunately, our services that we're creating and spinning up in these cloud providers aren't, they aren't called the same thing. They don't have the exact same inputs, right? So it's not in that you could use the exact same script from each one of these to provision your AWS, your GCP, your Azure environments. However, there's some consistent workflows, there's a consistent way in which you're provisioning, there's a consistent language, and there's a lot of shared duplication, shared library code that you can use amongst these tools. So quickly, for those who are new to Ansible, Terraform, and Packer, well, for each section, I'm just going to give a really brief high-level introduction from like their documentation page about each one of these resources, and then I'll just share a couple of tips, anecdotes that I like to use that have been really helpful when I think about provisioning really complex environments. So first and foremost, we have Ansible, taken from the documentation, is an open source software provisioning and configuration management and application deployment tool. It does all three, but I personally only use it for configuration management. It runs on Unix-like systems, and it has its own declarative language, as you can see here on the screen. However, it's very close, it's very clear and concise and close to a YAML-like syntax. It has a really clean hierarchical design. You can do some really neat layout of your Ansible code to allow for reuse. They have fun names, like you create a playbook that would have all the plays within it that define what roles should be consumed. And what's one thing to keep in mind, so as I mentioned, Ansible I use for configuration. So when I have a box, a Linux box that has come up in my environment, I use this to install Apache, to install Postgres, to configure exactly how my Cassandra database and cluster should look like. All of these things, as long as you have a consistent operating system, there's consistent configuration code. So something to keep in mind, right? You wouldn't want to switch or hard code yourself into using like an Amazon machine image. You would use something like Ubuntu or Red Hat so that there's a consistency across managing your configurations. So some of my Ansible anecdotes or tips. Make use of variable inputs. When you are invoking your Ansible plays, you can pass in variables in order to hard code, avoid hard coding values. So an example of this here, I have this Ansible playbook. Essentially, you just call your Ansible playbook and which play you want to use. And then you can pass in some of these extra variables. For example, my server ID, I want each Neo4j node that comes up to have a unique server ID. And so when I invoke this playbook on each one of those nodes, I can pass this in. And now within my Ansible, I can use that server ID and be able to do some configurations custom per node that comes up. Also really helpful, you know, when you just think about how you're building your code, just to be as flexible as possible. And flexibility is key when we're deploying in multi-cloud, multi-level environments. When is your friend. So Ansible has this really nice when statement that gives you a lot of execution control and flexibility that is especially important for varied environments. An example of this here on your screen is I'm creating a file system, but I only want to create that file system that doesn't have partitions before. But literally your when statement could be anything. I only want to create this or mount this drive if my GCP flag is set. I only want to, you could go on and on, right? It provides that flexibility, kind of that if-then control in order for you to customize what is happening while you're configuring your boxes. That way you can use the exact same set of code, right, in our different environments. Like we said, most of it stays relatively the same between our operating systems, but maybe a couple things here and there might change. Use the power of when in order to not have to duplicate the exact same thing, but for your GCP environment, right? Runtime variables are your best friend. So even more elegant than our variable inputs, and the when statement are these, there are three kind of like runtime variables that you can configure facts, setup, and registers. And essentially they enable you to create variables at runtime and provide even more execution flexibility. So looking at our code, you can see the three examples here. Ansible also provides some default configuration information about the box that has come up. So here I'm saving my IP address in this variable Ansible default IPv4 address. That is constantly going to be changing no matter what box you spin up, right? So being able to capture that and save that is really important. I can also create my own variables from known strings, known variable inputs. So we saw before we were inputting that server ID, but I also want to combine it with my service name. And now I have this completely unique host name that I will use later on in my configurations. And finally, even more elegant, right? I can execute a shell script. I can execute different functions within my Ansible step here, and then register the result of this shell script in a variable. So I'm using, in this instance, the AWS metadata API to get my availability zone of the current node, and I save that. There's a lot of beauty and flexibility in these runtime variables. So moving right along into Packer. Again, taken from the Packer documentation. Packer is an open source tool for creating identical machine images, and these can be created for a number of different cloud providers. So when you think of machine images, just think of a stored machine state with your operating system, some scripts, maybe tools that are already pre-installed. They help reduce your provision speed. And as you can see here, it's pretty simple and easy to implement JSON. And again, cloud agnostic and independent of having to manually create everything. It's all saved in code. Some of my Packer anecdotes and tips is combining the beauty and flexibility and power and features that we got from Ansible with Packer is possible. And this is one of my favorite things that I love. So you'll see here in this previous example, in your Packer scripts, you specify a little bit about your cloud provider. And this is very specific to each cloud provider. So again, there might be some duplication, but what's really nice is when you're now configuring what should your image look like, you do a provisioner step. And here you can see I'm just doing a shell, it sleeps, it updates apt, and then it installs Postgres. When you combine Packer and Ansible, you obviously install some things, install Ansible, and now I can run my playbook with all of that configuration code here and bake it into my image. And this is just a way to simplify, again, your tool set. Everybody's used to building with Ansible. We've got a wealth of knowledge on how to elegantly download different Debian files and how to copy over different configuration files. Utilize that power and that knowledge in my Packer scripts it reduces that time, saves on our headaches, and ultimately makes this process a lot smoother and more efficient and simple. Number two, so if you're anything like me, I hate working with JSON as much as I touted that it's easy to read. I think it's kind of a pain in the behind. YAML, conversely, though, is a lot cleaner, right, than JSON. You're able to define some commenting. Packers, when you use JSON, you can't have as much commenting within your code. And you can use aliasing within YAML, so things that are duplicative, right? Obviously, the parts that specify each one of our cloud providers in our Packer, like where I showed where that builder was, right? Those are going to be different, but for the most part, our provisioner would be the exact same thing. I can create an alias, so I'm not copying that code over and over again. And I just learned about this, being able to, this idea of taking a YAML file and converting it to JSON and then passing it into Packer so that you can utilize that YAML flexibility, and it can save headaches if you hate working with JSON, especially when it gets a little bit more complicated like I do. So essentially we're loading our YAML from standard in, we're configuring it to JSON, putting it to standard out, and it's as simple as cat your YAML file, put it into your transformer, and then pass that into your Packer command. Love it. But even cooler, so recently, I think it's been a little while since I worked with Packer. When I was looking at the documentation, Packer 1.5 supports HCL, which is HashiCorp configuration language 2.0. However, it's still in beta, and I'm not 100% sure if they've mentioned when they will be out of beta, but this gives us the power of variables and aliases and dynamic configuration. Like, I got so excited when I learned about this. And essentially it's the same language that we're going to be using when we use Terraform. Again, simplifying our tool set knowledge. It's the exact same relatively as Terraform, and providing a lot more flexibility to say, I have images that I want to create for GCP and for Azure, but they have these common denominators. Let me create some variables for them and then stick them in while I'm building my images. Last but not least, we have Terraform, which is an open source infrastructure as code software tool created by HashiCorp, same people who create Packer. And this enables you to define all those pieces and parts of your data center. So what nodes do you need? What load balancers? Do you need a database? And this is specified in that HCL Apache configuration language that I mentioned about Packer, that I'm really excited about having that similarity coming to fruition. And it really is just an elegant solution that is completely cloud agnostic, and has really increased the readability and maintainability of our infrastructure code. 2 quick tips and anecdotes about Terraform. Modules are your key to speedy provisioning. I have experienced this firsthand, how quickly having a module, which is just a container essentially for you to define multiple Terraform resources. So if I know that I have a Cassandra cluster, it always has to have a bunch of EC2 instances with a bunch of block storage on it. I can define a module around it that takes variable input and then be able to provision literally Cassandra clusters at the drop of a dime. You can see that here. So on the screen, we have our definition of what our module would look like. So it's defining some nodes, some network interfaces to attach to those nodes, and then my block storage that is also going to be attached to those nodes. And now, because I've set up this module, I can literally invoke the module, pass in some of these common input parts, and literally have an entire Cassandra cluster at the drop of provision speed. It literally has been life-changing. People are like, oh, Bri, I need to test adding a new, configuration to our Cassandra cluster, or modifying data to our Cassandra cluster. And I'm like, hey, let me go get you your own Cassandra cluster. It literally will come up in 2 minutes. They have their own Cassandra cluster, and then I can destroy it. And then they can move on and go and actually do these changes in dev, QA, prod, you name it. Last but not least, data lookups. enable enormous flexibility. So when you use data lookups in Terraform, what I love about them, usually Terraform, when you're provisioning a resource and it needs something like a security group, you have to provide the security group ID, which is like an alphanumeric, just random set of numbers and letters that's in like the AWS console. It has no meaning to me as a human being, and it is very specific per account that I have. So if I have a dev account or a QA account or an Azure account, right, I can't use that ID to build the exact same application in these multiple environments. And hence the power of data lookups come into play. So in this example, in our security group example, I can look up a security group. Instead of having to attach my security group ID, I can pass in a name. So in this example, I'm passing in WB console agent, and it will go in, pull out the security group and get me a security group object, and then I can pass in that ID. And what's really elegant about that is now I can name all of my security groups or these security components across my entire infrastructure level the exact same, and be able to look them up and provision infrastructure at the drop of a dime without having to go in and look at and change each one of those security group IDs. It also makes it a lot more easier for me to be like, oh, I forgot to add my all accesses instance group, instead of looking at security group 1, 2, 3, 4, 5, 6, 7, 8. Who knows what that is? So that was a really, really fast rundown at effectively managing multi-cloud environments. I appreciate you all for tuning in. It was just a little snippet, little nugget, since we only had 30 minutes today. But if you have any questions, I'd be happy to stay on the line. But hopefully you all will continue to learn lots and enjoy the rest of the conversations today at the conference.
I will moderate. You do have some questions. Do you use any CI/CD with these tools?
Yes, so we have actually, we automate, and this is where that like caveat of a little bit of Python comes in. So we've automated creating like Python scripts to invoke our Packer, to invoke our Terraform. Technically, we don't have to invoke Ansible because it's embedded in our Terraform, but we've made scripts and then we run those in Jenkins so that everything is completely automated. I don't have to sit here and type in Terraform apply my Cassandra cluster. I can go and hit Jenkins and it'll pick up my Python script, which has the Terraform command in it.
And one more question. Have you ever looked at SaltStack before?
What was that?
SaltStack?
I have not.
It's a company that VMware just acquired recently. It's just a question that someone asked in Q&A, so you answered it. Perfect.
I have not. I will have to take a look at that.
And I think that's it. Thank you so much, Briana, for taking the time. We really appreciate it.
Thanks for having me.
Have a great day, everyone.
You too.
Bye.